Hello students, I am V. Ragaswamy. Today's class I am going to explain about hydrocarbons. Acyclic hydrocarbons. Organic compounds contain carbon, hydrogen elements, and these are called as the hydrocarbons. These are the simplest organic compounds, and in fact other compounds are also considered to be derived from these hydrocarbons. Organic compounds are classified into different types based on the arrangement of the carbon atoms in organic compounds. These are the cyclic compounds, you can say acyclic compounds. Cyclic compounds have carbon atoms arranged in a ring and a cyclic form. Whereas the acyclic compounds have the carbon atoms arranged in a straight chain or branched chain forms. So acyclic compounds are further again, you can see the classified into different types depending on the carbon-carbon bond. So hydrocarbons. So hydrocarbons are the organic compounds consists only the carbon and the hydrogen bonds. This contain only the carbon and the hydrogen atoms. So hydrocarbons they come in different variety of the forms as I've told you. Yeah, it can be the gases, it can be the liquids, it can be the waxes, polymers, or different types. But these hydrocarbons, again, the simplest organic compounds, again, these which are derived from the hydrocarbons, and they are classified even depending on the arrangement of the carbon atoms. Depending on the nature of depending on their physical state, there are a variety of the forms as a gases, liquids, polymers. Gases we use here, the methane, propane, the liquids hexane, benzene, waxes, paraffin, or the polymers, polythene you can take. All these are the hydrocarbons. Polyester, regular, generally for clothes we keep using this polymer. Hydrocarbons are processed to create the plastics. After doing a lot of processing, so daily whatever we use, it's all the organic compounds in our daily life. Whatever is coming, it is organic compounds. Mostly we are coming across even in the what the drugs what you take, even the tablets what you take, daily using the compounds, generally all are the hydrocarbons, organic compounds and hydrocarbons. Hydrocarbons, that's the simplest class of organic compounds, non-polar. And these are four main types of hydrocarbons. Saturated hydrocarbons, alkanes. Here, what is a saturated hydrocarbons? The hydrocarbons, the carbon-carbons having the single bonds. The bond between this carbon and carbon is a single bond. And those are the alkanes. Alkanes again, CnH2n plus 2 is the formula. Methane, ethane, propane, that way the formula series continues. Butane, pentane, hexane, heptane, octane, non, and so on. So this homologous series is nothing but they get repeated with the bonds H2 bond, that group. And the saturated hydrocarbons are generally the paraffins, alkanes. These alkanes, they have the carbon single bond carbons. And the unsaturated hydrocarbons, where you can see alkenes or alkynes. See unsaturation, what it means. The carbon and carbon bond, you're having the triple bonds. Between the carbon and carbon, you're having double bonds or the triple bonds. That is the unsaturation. If it is having carbon, double bond carbon, then we call them as alkenes. If it is having carbon, triple bond carbons, then that is alkynes. These both of them come under unsaturated hydrocarbons. And now coming to the cycloalkanes, the other class of hydrocarbons. These are the cyclic saturated hydrocarbons. These are the saturated cyclic hydrocarbons, cycloalkanes. So you're having all the carbon, single bond, carbon bonds, but there is no starting in there. It's closed. They are the closed structures. And next, coming to the next class, it is aromatic hydrocarbons. It is the aromatic hydrocarbons. In the aromatic hydrocarbons, you are having carbon bond carbons, the ring structures. You are having the ring structures, and they are having the double bonds. There is unsaturation of the cycle, in the cycle of the hydrocarbons. If there is unsaturation of the carbon bond carbon in the ring, then they are the aromatic hydrocarbons. So different examples can be illustrated for them. So basically, the hydrocarbons acyclic or aliphatic, and the cyclic or the ring structures. Basically, the hydrocarbons are classified into two types: aliphatic or acyclic hydrocarbons, and the next one is the cyclic or the ring compounds. Again, under the acyclic compounds, you are having acyclic or aliphatic compounds. We are having the saturated hydrocarbons or unsaturated hydrocarbons. In the saturated hydrocarbons, as I told you, the alkanes. These alkanes are having carbon single bond carbon. And in the unsaturated hydrocarbons, as I told you, they are having multiple bonds. They are having the multiple bonds. It can be the carbon double bond carbon or carbon triple bond carbon. Example, 1-butene and 1-butane. 1-butene is example for the alkene and 1-butene for the alkyne. And the next one is a cyclic hydrocarbons. In the cyclic hydrocarbons, you are having two classes: alicyclic compounds, that is the cycloalkanes, and the next one is the aromatic hydrocarbons. In the alicyclic hydrocarbons, that is the cycloalkanes, there is a cycle, the closed structure of the carbons with single bonds. And in the aromatic hydrocarbons, there is a closed structure of the carbons ring structure with the unsaturation. The saturated means each carbon is bonded to 4 other atoms through single covalent bond. And hydrogen atoms usually occupy available bonding positions after the carbons and are bonded to each other. So in the saturation, it means saturation means each carbon is bonded to 4 other atoms through single bond covalent. That is sigma. It is the sigma. And the hydrogen's atom generally satisfy the this hydrogen satisfy the valence. Next, coming to the bonding positions of the carbon atoms, the hydrogens satisfy the valence of the carbon. In case all the carbon atoms are bonded well and good, if it is less, then the hydrogen atoms. Now coming to the unsaturation. Unsaturated hydrocarbons contain either double bond or the triple bond. Since the compound unsaturated with respect to the hydrogen, if extra electrons are there, they are shared between the two carbon atoms, form a double bond. As I've told you, the double bond, triple bond, you are having always the single bond is the sigma, and double and triple bonds are the pi bonds. Here, the alkanes, they're made only the carbon and the hydrogen atoms, also called as the paraffins. Single bonds only between the carbon atoms. So general formula we have discussed previously. The general formula is CnH2n plus 2. General formula is CnH2n plus 2, and non-cyclic structure. Here the name ends with the A. We'll see the nomenclature in the next slide. So alkanes, here you can see this ethane. This ethane, it is having CH3 bond CH3. This carbon bond carbon, this carbon is surrounding with the 3 hydrogens. and the other carbon it is surrounding with another three hydrogens. Here the carbon, single bond carbon, and the revalency it is satisfied by the three hydrogens. And here also the carbon it is satisfied by the three hydrogens. Okay. Now coming to the next one. Here coming to the next one, we'll see. Coming to the nomenclature of the alkanes. First, we'll see the methane. Methane. Here the methane it is CH4. IUPAC name it is methane. The molecular formula it is CH4. The structural formula carbon it is having 4 bonds with the hydrogens. The boiling points it is here. It's given my here for you. And coming to the next one, the homologous series CnH2n plus 2. So CnH2n plus 2. So here one more CH2 is added here. Homologous. So CH4. Here the N value is 1. Here this N value is 2. So substituting the formula CnH2n plus 2, N is equal to 2, you will get ethane. C2H6. C bond C, and it is having 3 hydrogens. And this one it's having 3 hydrogens. And coming to the propane, for ethane structure, for methane N is equal to 1. The formula is CnH2n plus 2. If N is equal to 1, that is methane. If N is equal to 2, then that is, if N is equal to 2, it is ethane. If N is equal to 3, that is propane. If N is equal to 3, N is equal to 3, that is propane. N is equal to 4, it's butane. C3H8 propane formula, you have to write CH3, CH2 and CH3. Next, in butane, N is equal to 4. N is equal to 4 for the butane. CnH2n plus 2. C4 H2O plus 2. So it is C4H10 and the formula is CH3 CH2 twice CH3. Now if N is equal to 5, N is equal to 5, then that is pentane C5H12. C5H12. So straight you have to write, or else branching means you can write. You get N-pentane, you get the isomers, isopentane, neopentane. So for N is equal to 5, you have to substitute N is equal to 5, CnH2 plus 2, you get C5H12. CH3, CH2, thrice CH3. Hexane, it is C6, H14. N is equal to 6. If N is equal to 6, yeah, CH3, CH2 4 times and CH3. If N is 7, substituting in the formula, you get heptane, C7, H16. If N is equal to 8, you get octane, C8, H18. If it is N is equal to 9, C9, H20. If N is equal to 10, it is C10, H10. Here we have named different compounds. The alkanes, saturated hydrocarbons, alkanes, Pepsi. Many of these alkane substances we are familiar because of their widespread use. Generally in the cylinders, the regular what we are using, the gas cylinders, for camping, the stoves, lanterns, all these we use this gases. Most of the alkane substances here they're familiar. Example, methane, a major component of the natural gas. Propane, major component of the bottled gas. Next, butane, it is used in the disposable lighters and fuel canisters for gas, camping the stoves and the metals. And the alkanes that are with from 5 to 12, that is from pentane to hexane, it is in the gasoline, molecule found in the gasoline. Now we'll see the organic compounds. We'll see the organic compounds with different functional groups. Now, in these aliphatic compounds, if depending upon the functional group, we can name the compounds. First, I've told you, if hydrogen and carbon it is having single bonds, then that is alkanes. If carbon and carbons, if carbon and carbon, they are having the double bonds, then that is alkenes. If carbon and carbon, they are having triple bonds. In case if you have single bond or double bond, still we give priority to the triple bond. So you call it as the alkynes. In the compounds, you may have C single bond C and C double bond C. Then you give priority to the double bond. In case if you have C single bond C, C double bond C, C triple bond C, C triple bond C is given more priority. Then C double bond C, and then goes the priority to the least priority to the alkenes. Now coming to the aromatic compounds. As I've told you, the carbon, if there is a ring structure, then and it is having unsaturation, then that is called aromatic compound. Next, if you can see here ROH, R is the alkyl group. How do you get the alkyl group? Alkanes, one hydrogen is present, bond alkyne group is there. See, that is the alkyl group. You represent with the R group. One hydrogen less to the alkanes is alkyl group. One hydrogen less to the alkane is alkyl group. It is denoted by R. Now, if ROH is there, here the functional group is OH, oxygen, OH. Then these are called as the hydroxy compounds we call. Under hydroxy compounds, if R is aliphatic, then that is alcohol. If R is aromatic, then we call it as phenols. Now, coming to the ethers. See, alcohol and ethers almost the same, but in place of hydrogen, we are having the alkane. If ROH is there, you call alcohols, ols. At the end, you denote with ols. Next, that is ROH. Methanol, ethanol, propanol, butanol, hexanol, heptanol. So at the end, we call it with ols. If ROH function group is there. Next, coming to the ethers, the next function group. In these aliphatic compounds, may be saturated or unsaturated. If the RO is present, then that functional group is ethers. So two alkyl groups are bonded to central oxygen, that is ether. We have different examples for these ethers. Diethyl ether, methyl ethyl ether, diethyl ether or dimethyl ether. These are the best solvents for the organic compounds. So this ether, in these ethers, ROR is the function. So you name the alkyl group here, you name the other alkyl group. Combine for this. For example, CH3 goes with dimethyl ether. If CH3 will C2H5 is methyl ethyl ether. If two ethyl groups are there between an oxygen, diethyl ether. So the alkyl naming by the alkyl groups, we name the ether. Now coming to the next one, it is aldehydes. Aldehydes. Aldehydes you can see here R, C, double bond O, H. Now coming to the carbonyl compounds. What are the carbonyl compounds? These carbonyl compounds are the compounds having C double bond O group. Bond C double bond O bond group is a carbonyl group. If these carbonyl groups are present, these carbonyl groups again you can classify into two types, aldehydes and ketones. In the bond C double bond O bond, if RCOH is there, if RCOH is there, here RC double bond H is there, that is aldehyde group. You call it as ALS or aldehyde. Now I'm going to give some examples in the aldehydes. If R is a CH3, so CH3, CH2, then here two carbons are there in aldehyde group is there. You call it as ethanoldehyde. Common name is estaldehyde. In case if there is no R group and hydrogen is only present, then we call it as methanoldehyde. IUPAC and formaldehyde is a common example. So if CH2 group is there, then that is aldehyde, and at the end we call aldehyde. HCHO, formaldehyde or methanoldehyde. CH3, CHO, then that is ethanoldehyde or estaldehyde is the common name. Similarly, if CH3, CH2, CHO is there, then that is propanaldehyde. In case if there are the R group, if R group it is having butyl group and one more aldehyde group, combined you get as pentanaldehyde. Similarly, pentanaldehyde or pentanol. Again, depending on the position 1, 2, 3. So generally all the aldehydes are one aldehydes. Okay. So one aldehydes. The CHO group will be at the end. Next, coming to the aldehydes, ethanaldehyde, propanaldehyde, butanaldehyde, hexanaldehyde, similar, heptanaldehyde, so on. Like that, you get different types of aldehydes. Here the function group is CHO. The function is CHO. Now coming to the next one, as I've told you, the carbonyl compounds are divided into two types. One is aldehydes. The second carbonyl compound is ketones. Ketones. Ketones, you can see here the difference between these two. Here RCOH. Here you are having RCOR. That is ketone. Both the positions you are having the R groups. So RCOR. Here you can see ether. It is ROR. ROR. But here for ketones it is RCOR. So R is the alkyl group. It can be same or it can be different. We call it as ketones. Known, you'll be getting at the end suffix. Knowns. See here. These ketones start with a minimum of 3 carbons. R is a carbon group. Here R is another carbon group. Carbon, carbon, carbon. 3 carbons are there. So here 3 carbons are there. So a smallest ketone will be having minimum of 3 carbons. So acetone is the simplest ketone. CH3, C1, CH3. Similarly, it can be CH3, CO, C2H5. So propanone, butanone, pentanone, hexanone, that way you can, or else dimethyl ketone, diethyl ketone, dialkyl ketone, that way you can call. Now, coming to the next group, when here, the next one is the esters. You can clearly see here, esters. Here, ester. R, C double bond O, R is the ester. R, C double O, R. Here, one more oxygen is increased. Ketone you're having R, C, O, R. Here you're having for esters R, C double bond O, R. One oxygen is extra here. This is called ester. Here, R, C, O, R is called ester. R is the alkyl group. C, O, R, R, C, O, R is ester. So at the end you call it as O8 for esters. Dialkyl ester you can call, or O8 you can call. Okay. For example, if you are alkyl group, you are having CH3. One more here you are having CH3. Dimethyl ester or CH3, one carbon, here CO, third carbon, and here one CH3. Methyl acetate, like that, you call 8O8 or ester you call directly. Next functional group, the next one, it is carboxylic acids. Previously I have told you RCOOR. Depending upon the R, you give the number of carbons and you name it as O8 or esters. Here for the acids there is slight change. In place of R, CO, O, R, you are having H. If it is an ester, if it is ester, if it is ester, here. Sorry. So if it is ester, you are having R, COO, R. If it is a carboxylic acid, you are having if it is carboxylic acid, it is RCOOH. See, for carboxylic acids, if the R group is H here, then that is, if it is H, then that is formic acid or methanoic acid. If R group, it is H. In place of R, if you are having H, it's formic acid, or if it is formic acid, or it is methanoic acid. At the end, you call oic acid. Next, carboxylic acid. If it is R is CH3, if R is CH3, then that is acetic acid. If that is acetic acid, or else ethanoic acid. In case if it is 3 carbons, then propanoic acid. If it is 4 carbons, then that is butanoic acid or pentanoic acid. Similarly, oic acid is something that will be following for these acids. Next, coming for the amines. Coming for the amines. Amines here, you're having nitrogen, you're having 3 R's. Whatever it may be, if it is NH2 group, then that is amine. If it is NH2 group, then that is amine. If this NH2 group, if it is having 1 R, if it is having 0 R's or 1 R, then that is primary amine. If the nitrogen is having 2 R's, then that is secondary amine. If it is having 3 R's, then that is tertiary amine. So these amines are primary, secondary, tertiary. At the end, you call it as amines. Methylamine, ethylamine, dimethylamine, diethylamine, trimethylamine, triethylamine. That way you call at the end amines. So bond NH2 will be hard. Now coming to the amides. A slight difference between amides and amines is the function group. Between R and NH2, you are having a CO group, that is amide. For R and N, for R and NH2, one CO group is there, that is amide. So CH3, CO, NH2, acetamide, acetamide. If R, if R is CH3, CH3, CO, NH2, acetamide. If C2H5 is there, ethyl group is there. And CO, NH2 is there. So 3 carbons with NH2 for amide. Similarly, butanamide, amide. So CO, bond, CO, NH2 is there. That is the nomenclature. So in detail, we'll see in the next class. So this is a brief introduction of the function groups, hydrocarbons, and how these hydrocarbons are of different types we have seen. And in this, just giving the functional group for his aliphatic compounds or the aromatic compounds we have seen. Yeah, what is organic chemistry? The study of the carbon compounds. The first known organic compound is from animals and vegetables. They are crystallized and purified. Here, Tobin Bergman was the first person to express the difference between organic and inorganic substances. And the phrase organic chemistry and the chemistry of the compounds from living organic, everything is explained. So this very important role is in these days, this organic compounds contain the carbon and hydrogen elements play a vital role in today's chemistry. This organic chemistry. So in the drug discovery, everywhere, there is a great importance for this organic chemistry. So nowadays in this pandemic situation, you can see how organic chemistry is playing a vital role. We'll take some of the examples. Organic chemistry, because the study of, you will be having the study of the life and all the chemical reactions related, and several careers apply to organic chemistry. Pharmacologists, analytical engineers, chemistry, everywhere is organic chemistry. And there are this organic chemistry study of the structures, properties, composition, reactions, the preparation of the carbon containing compounds, hydrocarbons, and number of carbons. It has a great importance. And in daily life also, see, daily life you have the chemistry, shampoo, gasoline, perfume, lotions, drugs, food additives, plastics, papers, everything, whatever it is, plays a very important. And to many chemists at that time, there's only explanation of the difference between the organic and inorganic compounds. Organic compounds contain a peculiar vital force theory. And later on, it was derived from the living organisms. That is from animal fat. They have discovered the soap and the glycerin, and the soap again on hydrolysis is giving the fatty acids. So why this carbon so special? It has apart from other elements in periodic table. Yeah, the ability of this one, it is having, it can form long chains and rings. It is having the catenation property. The ability of the carbon to bond together form it can form long chain. It doesn't require anybody's help. It's a catenation property, carbon self-linking property, carbon bond, carbon bond, carbon bond, infinite bond like that. And the second one is it is having the vital force. It is having this tetravalency. All the four sides can bond for itself. A carbon alone of all the elements is able to form the immense diverse compounds. So previously we have seen in the previous slides different types of compounds what are formed. So immense diversity of the compounds we have seen from the simplest to staggering complex. We have methane to DNA to take the bodies. It contains hundreds of billions. Yeah, the carbon compounds. Okay. So this is the importance of the carbon chemistry. So, what are the hydrocarbons and how they are of different types and what are the different functional groups? Everything was explained to you. I hope you have understood my class. So, what are the hydrocarbons we have seen and the varieties of the hydrocarbons we have seen? What is the saturated hydrocarbons, unsaturated hydrocarbons? What are the alkanes and different types of alkanes we have seen? And similarly, alkanes, different functional groups. And even the alkanes, the double bonded compounds, alkanes, and the triple bonded compounds are the alkanes. In the alkenes and alkynes, you can see. In alkanes, we can see the conformational isomerism, carbon bond, carbon rotation, and different conformations we can see. And in alkanes, there is a restricted bond rotation. So in this restricted bond rotation, you can see a geometrical isomerism for the C double bond C and C triple bond C. We have a cis trans isomers. So this type of isomerism is exhibited in the alkenes and alkynes. So alkenes, different compounds you have in methane, methane it's for alkene, ethene, propene, butene, pentene, hexene, heptane. So depending on the positions 1, 2, 3 like that you can remember depending on double bond position. And for the alkanes also you have carbon triple bond carbons and most priority is given for the triple bond than the double bond single bond. And in the C triple bond C, even these compounds exhibit the geometrical isomerism, which is having these are the stereo isomers, which is having a carbon single bond restricted rotation. There is a restriction in rotation of the carbon bond carbon due to triple bond, and thereby you can see the geometrical isomerism in the alkynes. And we have seen the different functional groups in this hydrocarbons in the important families of the organic compounds. Alcohols, ethers, aldehydes, ketones, esters, acids, amines, amines. So what is the functional group and what are the examples? And what is in organic chemistry? Why studying these carbon compounds? How it is what is the how it's first known, from where it's known, we have discussed, and how important it is in today's life. It plays a major vital role in today's chemistry. Say organic chemistry, why it has arrived, and it's only due to carbon. Well, that's why it's called carbon chemistry. Why it's so special? Apart from other elements, just because it is having the catenation property, self-linking of the atoms, it doesn't require the help of any of the atom. It can link for itself infinite times. So it is having a tetravalence. The unique ability of the carbon to bond together, forming the long chains and rings, and function groups and different compounds, a variety of compounds. So carbon alone of elements is able to form immense diverse compounds. So this organic chemistry, it's having a lot of organic chemistry. It's a wide field covered by other elements. So its scope embraces all the living matter as well as a vast number of the non-living substances used for agency. So this organic chemistry is infinite. Is the branch that studies the properties of all the organic compounds. It is a creative science in which the chemist creates new molecules, explore the properties of the molecules. The organic chemistry is highly creative science where the chemists create. It's a creative science where chemists create new molecules. They explore the properties. In this pandemic situation, also you can see how the chemistry is playing a vital role. See, all this, it is due to the carbon and the unique ability of special properties of the carbon. Thank you, everybody. I hope you have understood this.